Hi, everyone. I'm just going to go ahead and go through chapter 5-3's homework. So for those that weren't in class, couldn't get the help with it, at least hopefully this will help you get through it. So again, I'm also doing it on the Promethean, so I can't really record any of the gestures I'm making. So I'm just going to go ahead and get started here. You do have 6 problems. They're very much what you see, and if you were in class, it's the exact same as what we did there. So the first problem is going over function notation, which is just saying you're going to plug in the number to that function that they give you. So for f of -7, all you're going to do is change that x value to a -7 and simplify as needed. So we're going to do f of -7 equals 4. And instead of writing that x, I'm going to put a -7 in plus 4. And simplify as needed. So 4 times -7 is -28. Add 4, and I'm going to get -24. I'm going to do the exact same thing for g of 5. Plug in 5 into the g function. So g of 5 is -3, and I'm only replacing the x, not the exponent as well. So -3 times 5 squared minus 2, and I'm going to simplify, so keep my -3. 5 squared is 25 minus 2. -3 times 25 is -75 minus 2, which is equal to -77. So I'm going to go ahead and just plug in -24 and -77. -24. Okay. -24 and -77. I'm going to hit check. And they're right, so that's great. So now I'm going to head and move on to question 2. All right, so next we're going to take a look at leading coefficient and degree. Leading coefficient comes from the vocabulary review we did at the start of class. And a leading coefficient is what leads the equation when we write it in standard form. So if I were to write this equation in standard form, I would base it on the exponents. So my v cubed term would go first, then v squared, then v, and then my constant. So this is really saying I have 5v cubed plus 4v squared plus 5v minus 18. So the reason it's called a leading coefficient is because when we do it in this form, it starts off the problem, and that's my leading coefficient. My highest exponent is going to be my degree. So I'm just going to go ahead and write that in, 5 and 3. So for leading coefficient, we're going to head and put in a 5. And for my degree, we're going to head and put in a 3. Go ahead and hit check. And that's all you need to do for that problem. Not really trying to trick you, that is actually all they want. All right, next we're going to take a look here at where it says solve for w, where w is a real number. We did go over this in your class. That hopefully you can go ahead and do this, because again, I told you this board does not like Desmos. So I'm going to take w cubed equals 27. We're going to take the third root. So there's going to be a little 3 in this little nook here that tells me we're doing the third root. And I can type this in the calculator, or I can go ahead and just happen to know that 3 cubed is 27, so my answer is 3. So we do have a couple options. You can use the Desmos calculator, you can use Google, and go ahead and do that. I can't really show you typing it on the calculator, it doesn't like that. So I'm gonna do this up here and type in a 3. And we can go ahead and do it that way. So next we're going to hit continue. No, I don't want to say my password. All right, next we want to go ahead and find our X and Y intercepts. So one of the nice things is that this is in standard form. And we kind of briefly talked about this, but whatever your constant term is, and so in this case, my constant is 0. Whatever your constant term is, which is the term without a variable attached to it, that's actually your y-intercept. So I know my y-intercept is at 0, which also tells me that my x-intercept will be at 0 generally. So I would actually go ahead and graph this. I'm going to see if Desmos will let me graph this or not. By opening a new tab, we're going to hope maybe it will let me. And I want 3x cubed, so I'm going to start with that. And it's already, I can already tell it's not going to want me to do it. Yeah, let me put in the 3. So what I'm going to head and do is actually, I'm going to switch screens to what's on my computer. All right, so we're going to head and use this one here. And I just need the equation really fast. All right, so based on what I had on the previous screen, 3x, and I can get my exponent 2 ways. I can either do Shift-6 or press this A to the B button to do a 3. And I'm going to do plus 3x squared minus 18x. I do like Desmos just because it does show you automatically where everything is. Oop. Oh, minus 18x, my bad. It automatically tells you where it crosses. So I can see it crosses at -3, 0, and 2. So that is what I would go ahead and input for my lovely problem here. So I'm going to go back to shift screen this way. Going back to Alex over here. All right, so I can go ahead and type in what we had, which we said 0 for my y-intercept. And I'm going to make my list of -3, 0, and 2. You don't have to do them in that order. I just like to go ahead and count up. It's just how I normally do things. But it should technically take it in any order that you write it in. All right, moving on to question 5. As always, you're welcome to pause the video to whatever you might need to go ahead and do. All right, so for these here, you can either use the chart we had in class that talked about end behavior based on even and odds, or you can go ahead and graph both of them, all 3 of them. That is a choice. So it is one of those things that's helpful to know that this is an even function and it's a positive leading coefficient. So I may not know what happens in the middle, but I do know it looks like that. B is an odd function because my degree is odd. And I do know it's a positive leading coefficient. So it does look something like this Again, don't know the middle, but I do know what my ends look like. So I'm gonna have x squared times 3x, which gets me 15x cubed times x is still positive. So this is a positive even. So it's gonna look something with both arrows going up, but we could always go ahead and check this in Desmos, which I'm gonna head and do by sharing my computer screen again, by switching between the two. So I'm gonna graph the first one, x to the 6th plus 9x to the 5th plus 2x squared minus 3. I'm gonna head and zoom out so I can see what's happening. And I can, if I really zoom out, it's really ugly actually. If I'm gonna change my settings. I only want to count from -10 to 10. And let's do -600. Actually, let's just do -1,000. We can do that. Still doesn't actually get me to how far low it goes. How low does this thing go? So I'm going to do this. I can do -6,000. Okay, and if I super zoom out, and I can go ahead and change the that's quite a jump. I'm going to change my x-axis so it's a bit more manageable to see it. 10 to 10, with this one being negative. So if I really zoom out and I look at a small section, this is what it looks like. And I can see again, both at the ends, it's both pointing up. So I am going to go ahead and go with what I had up on my previous screen. And then I'm going to go ahead and graph the second one. 2x cubed, and we're just going to graph all 3, and then we'll talk about the wording that they have for the homework. Plus 6x plus 3. This one I do need to just go ahead home, and it looks much better that way. You can see it starts at the bottom and goes to the up forever. And our last one, which generally might be the one you need to go ahead and just graph in general, just because of the way they put it. And we did find out in class, actually, I was working with somebody else's, you do need to, when you're typing in this first one, if you're using the school calculators, you do need to go ahead and put parentheses around that first term of 5x squared. Otherwise, it might not work out the way you want it to. The calculator is just going to read it a certain way. I can go ahead and set these settings to be -100, 1,000, or 5,000. There we go. Negative, looks like I can do -3,000. We'll just go to 1,000 here. So that's about what it looks like. Both ends are pointing up. So I am just going to head and go over the vocabulary that they use on ALEKS. So on this first one, we know they're both pointing up. So as we go to the left, it rises. As we go to the right, it rises. So when I'm picking my answer on this one, I'm going to pick rise and rise. On part 2, I can see as we go to the left, it falls. As we go to the right, it rises. And lastly, for part C, I can see as we go both left and right, it rises again. So I'm going to head and share that in the homework slide. Share. All right, so for this one, we said rise and rise. So I'm going to pick this one here. We said falls to the left, rises to the right. And we said rise and rise. This is false. And again, so we did have kind of sketched out what they would look like. Again, I only sketched out what the ends look like, not what the middle part looks like. So go ahead, hide that and hit check. The vocabulary they use here is a little bit easier than what they would actually use probably on the SAT or ACT, that vocabulary and that notation that we're going to be looking for. So we'll go over that more in class as needed. And for the last question, it's actually just a graph and match it. So I am going to head and graph both of these in Desmos again. I'm just going to go ahead and do that, and then I can just switch over there and show you what they look like. Plus 8x squared and x plus 4 squared times x squared minus 1. All right, so based on what I'm seeing on my own screen, we can narrow down quite a bit. I'm gonna hit the home so I can see the middles. You do need to reset so that you actually do see the middle parts. I was zoomed out too much on my Desmos to see that. So I can sketch it. I can see that on, I'm taking a look at my computer, and I will go ahead and share this screen so that you can see it as well. All right, so what we have here is I'm taking a look at the second one, but let's go ahead and take a look at that first. And I'm just looking for the graph that will match that pattern. When we go back to it, you will notice that they didn't actually give me any Y range values. They just said, this is the general pattern from this X value to this X value, but they don't actually tell you at what Y values certain things are. So I can see here, it touches at 0 and then goes back up. So when I'm looking at that, that is actually giving me a very clear answer for what I'm looking for, because this first part is above, and I'm only below once I get to 4. After that, everything before 4 is above and positive. So that does help me out when I go back to Desmos or to the ALEKS problem. And then looking here at my second one, I want both my end behavior to be going up. I'm going to touch at -4, go back up, cross at -1, and then go back, turn around and go back up, crossing at 1. So that does give me a couple of clear things to take a look at. And that's all you really need to do for that problem, is to graph it and compare to what you see on your screen. So based on what I have here, so for that first one where I said it touches at 0, goes back up, and everything stays up, I would go with that is graph C is that first one. So I would choose graph C. And then for that second one, it crosses at it touches at -4, goes back up, goes down, which looks like graph F. Let's choose graph F and hit check. And that is correct. So graphing them on Desmos actually will help out quite a bit. You might need to play with the zoom feature to figure out kind of where you need, but hopefully that does help you out with this homework. As always, reach out to me, rewatch the video, ask me questions, and I will go ahead and help you. But I will see you next time.